Okay, 235. So we are going to skip the first page. Yeah, we're skipping the first page. We're going to go to this page. So 236. All right. Yesterday you did a bit of graphing, right? Did we do that? Did we do a bit of graphing yesterday? Okay. So you did it with a table of values, I believe. Like this thing. If you had an X value, you'd get a Y value. Did you do that? Table of value. Or you did that in grade 9? Did we do tables of values in grade 9? You put in an X into the equation, it spits out a Y value. Anyway, this is one way to represent the data of some function, okay? You have an input and an output. The other way is through ordered pairs, which you also did yesterday. They list them as S and C. They should just say X and Y. All right. The X value, then the Y value. Just like I had the A up here, it has an X and then a Y. These two things represent the same pieces of information. They're just written slightly differently. Okay. There's also a graph. Now I'm just going to connect them all. So this graph represents all this data as well. Okay. They're all the same thing. All right. They're just different ways of representing the data. The value of graphs is you can quickly look at it and you get a visual representation of what's going on. It's easy to see patterns and things like that, which I'm sure you've done in science class. The other way, we don't use it too often. In this class, you won't see it very often at all. It's called mapping, but it's the same idea. This is your X value. This is your Y value. So the point 20 and 10, 20 has an arrow. You can find it. There's so many arrows going all over the place. 20 would have an arrow going to its, see, I drew the arrow wrong. There we go, to 10. Okay, so that would give you the point 20 and 10. But 120 also has a value of 10, so you have an arrow from 120 to 10. It's just another way of representing the data. I think it looks more confusing than anything else, but it's there. Okay, we're not going to use it that often. We're going to focus on the table of values and graphs. Okay, that's all I need to say about that page. Going once, going twice. Ready? All right. Independent and dependent variables. On page, what page is this? Page 238, please. All right. So we're just going to focus on this table here. The independent variable in 99%, but the way all equations are written that we're going to see is the X variable. Okay? The X value is independent because you get to pick it. That's why it's independent of anything else. You put in whatever X value you want. All right? The Y value is the dependent because it depends on what X value you put in. So for example, so the dependent is going to be our Y values, or Y variables. So for example, if you're doing a table of values, X, Y, and we'll use this equation here, and I say X is 0, I get to pick 0. It's independent of everything else. If I put 0 into this equation, what do I get out? So I put 0 in for X. I'm going to get 3 times 0 minus 5. What's 3 times 0? Minus 5. Negative 5. So that means when X is 0, Y is negative 5. If I said X is equal to 1, what number would you get out? You get negative 2 because it would be 3 times 1 minus 5, which is 3 minus 5, which is negative 2. Okay? Is that okay? So this is the independent, and this is the dependent. Oh, and the other thing, and when you plot these, Which is the x-axis, the vertical or the horizontal? The horizontal. So that means the independent variable is on the x-axis. It's always on the horizontal axis, and the dependent is on the vertical axis. So it's not always going to be x and a y. They'll have different variables, especially if you've done science, you're plotting like temperature and time, things like that. Okay. May I flip the page? All right. All you have to do is tell me the independent and the dependent variable. So let's start with the B, the table of values. Now they're not using x and y anymore. They're using v and a. So which is the independent? What would be the x value? What do you always write first? You always write the number on the left first, right? So this is like your x, which is your independent. And a is like your y, which is the dependent. Okay, what about C? C, these ordered pairs. Which is the independent variable, which is like x? The B. All right, so these are ordered pairs. It always goes x and then y. So x is the independent, and this is like your y, which is the dependent. What about the first one, P and Q, in this mapping thing? P is what? Like your x, which is the independent. So this is your dependent. Okay. Whoops. Okay. Stay. Anybody know what that formula means? This is a side. Sorry? C is equal to 2 pi r. What does that mean? R is radius, that is correct. And C is circumference. So it means 2 times pi times r. The two variables are C and r. Which one is independent? R is independent. The one that is in the formula, like, is basically to the one that's not by itself. Let's start with that. The one that's by itself is the dependent, because C depends on what you pick R to be. So this is dependent. This would be independent. What about the graph? Which one? You have two variables, time and height. Which one is independent?
Time is independent and height is independent.
Exactly, because the independent always goes on what axis? The x-axis, which is the horizontal. So this is independent, and this is dependent. All right. Is that okay?
Can I go to the washroom?
Are we okay? All I would like you to do is 2 and 3, please. All right. We're going to complete this table of values. So they give us the equation y is equal to 2x minus 5. And they want us to finish this table of values. They give us the inputs. -2, -1, 0, 1, 2. I think we should do 6 and... What's another number? Give me another number. 15. No. -3. All right, so these are our x values. They go in for x. So it's 2, bracket, put in your x value. I know some of you can do this in your head. If you can do it in your head, that's fine. You don't have to show all your work. What's 2 times negative 2? Minus 5. Negative 9. So when x is negative 2, the output is negative 9. Okay? I'll do one more, and then you're on your own to finish that table. So, put negative 1 in. What's 2 times negative 1? Negative 2. Minus 5 is? Okay, go. Finish the table, please. You don't have to write it all out. If you can do it in your head, that's fine. You ready? Are those the numbers you got? Okay. We can write these as ordered pairs now, because ordered pairs are just putting them in brackets with the x first and the y second. So across the top here, the ordered pair is negative 2, negative 9. What? Okay. Do we have our ordered pairs? Plot them on the grid, please. So, negative 2, negative 9. You always start at the center. Negative 2, so you go to the left. Negative 9, you go down 9. There's your first point. Negative 1, negative 7. 1 to the left, down 7. Those are the points you should have gotten, or something that looks like that. Did people get that? Do people know how to do this? This is really important. Yes, yes. No? Once you've got the points drawn out, connect them with the lines, please. And then draw a line. Why can I draw a line through them? Those are all true. But what is the reason based on what we just did, what you did yesterday, and what we did right at the beginning of class? They are continuous variables, right? Because I could have put in decimals if I really wanted to. Oops. And there's your straight line. Okay. The only question I want to answer here. So this is called, when you have a straight line like this is called a linear relation. This is a linear line. It's straight. That's what linear means, okay? Straight enough. Grade 9 in the lesson. We're going to do it again. Okay. Any questions about that? All you're doing is putting the x values in. Once you get your xy points, plot them on the grid, draw a line through them. Is that okay? Congratulations. All right, if you flip to the next page, 241, we have this lovely equation. Y is equal to x squared minus 6. They have given us all the x values to input. What do you want that one to be? Negative 4.
It makes sense.
I do have to agree that it makes sense for it to be negative 4.
Yeah, well,
Okay, so we'll do the first one together because this one has a slight trick to it. I wouldn't say a slight trick. It's a little different. When I put x is equal to 4 into here, it looks like that, correct? It's the 4 being squared. You have, now this is very, very, very important. And to some of you, you're going to roll your eyes, but I've had grade 12s that'll mess this up, okay? Can I go 4 minus 6? Why not? Because of brackets and exponents. What's the rule called? BEDMAS. Brackets and exponents. We have both of them here. Do them first. So you square the 4. What's 4 squared? 4 squared is 16. So I get 10. Let's do one of the negatives. Let's do the negative 4. What happens when you square negative 4? Okay, what's negative 4 squared? Positive 16, right? Because negative times a negative. So you get 16 minus 6 is 10. All right, do the rest of them, please. And then do the order. Then do the ordered pairs. Please. What? Hang on one sec. Scaring me for a week. Are we done? Are we ready? It's all right. I'm just so excited.
Are we just doing this part or the part on my side?
We're going to sketch it on the graph. So if you've got the ordered pairs, you can plot them on the graph if you want. You done yet? No. Sorry, one of the kids gave it to me in my previous classes. You can get some of this if you want.
Oh, I'll take it. No. Right here. She got
I thought we were stealing someone's chips. No, he was like, don't punch like the vending machine. He was like, what?
That's just good.
And then it fell, and then he was like, hey, whose chips are you? No, and then we're trying to work it in his like class.
Okay. All right. Whoa. Is that what people got? 10, 3, -2, -5, -6, and then they repeat and they go back up. Same numbers. All right. Sketch it on the graph, please. Do you want me to pause it? Yeah, and then draw the line, please. You should need a ruler. You can borrow, but it's not a straight line.
But it can be a straight line in between.
Not really, but but if you draw it with a straight line, it's not that bad. I don't think if you applied the points right, you'd be okay. Are we ready? Are we ready? Are we ready? Oh my god. Are we ready? Are we ready? So your graph? It's not a straight line. It is not. It's a V shape. It's not quite a V shaped because it's curved. It's actually has a fancy name that you don't have to remember. In grade 11, you study this type of curve, basically the whole course. It is called, but I will never ask you this. How do you say that? Parabola. That's what everybody says. It's actually called parabola. Pronounced parabola. Okay? It is basically what you study in Math 11. Like these curves all the time and what they do and how to move them and all this kind of stuff. But we're not going to study them in particular. But the point of this is this a straight line? No. So we call it a non-linear relation or function in this case. It's non-linear. That's all you have to remember. It's non-linear. It's not straight. It's not straight. It's non-straight. Okay? That's all it really means. It's not a straight line. All right. Now let's look at the first equation. This one had an equation of y is equal to x squared minus 6. The very first graph on the previous page had the equation, what was it, 2x minus 1? Yeah, it was 2x minus 5. Okay. Linear, and that's obviously not. Okay, so this one is linear. This one is non-linear. Let me write something else. If I write y is equal to 3x to the fourth plus 1, and y is equal to x minus 1. This is nonlinear. X to the fourth, this is nonlinear. This is linear. Now, that's not a lot of examples, but can you come to a conclusion about how to know if a graph is linear or nonlinear?
If it's straight.
Without looking at the graph.
Oh, okay, never mind.
Just looking at the equation. Just looking at the equation, can you tell if a graph is not? What is that? It's got an exponent? Well, they both have exponents. That is it. What were you going to say, Ryan? You have a what, sorry? That's it. So, you were all sort of right. Okay? If the exponent is not 1 on the variable, because these ones have an exponent of 1, we just never write it. If it has an exponent of 1, it is linear. If it has any other exponent, it doesn't matter if it's like a half or negative number or anything, it is nonlinear. Okay? In Math 10, when we actually get into graphing, we only study linears, like their equations. But in the functions unit, which is coming up, we will look at nonlinears, but we won't really deal with their equations. We'll just kind of answer questions about the graph and stuff. But Math 10 is all about linear stuff. Grade 11 is about quadratics. This is called a quadratic function because it has a power of 2. And then Math 12 is every other function in the world. No. Well, not in the world. Most of them, and then calculus covers the rest of them. Okay. The only questions I want you to do are question. Where did I write this down? I want you to do 5. No, do you want to do 7? 5? No, not 5. 7C. Just do 7C. If you can do 7C, all I want you to do is graph it. So if you go to 7C, there's 7C. There it is right there. This one. I want you to do this equation right here. Fill out the table and sketch the graph. I will point out one thing, peoples. When you have this negative in front here, it actually means this. Negative, square the x, and then add the 5. So whatever number you put in for x, you're going to square it and then multiply by negative 1. Whatever. So if you put 4 in, what's 4 squared?
16.
Times negative 1 plus 5. Negative 11. So do that for the table and then graph it